So the next topic I want to talk about is asymptotic distributions and what people mean when they talk about asymptotic distributions is the central limit theorem. So when I say asymptotic distributions, what do I mean? An asymptotic distribution is, I cannot spell. So when I say asymptotic distribution, I'm talking about the distribution of some sequence or of distributions, we'll call them y sub n, as n converges to infinity. So for example, this could look like, I'm just going to draw some graphs. Maybe n equals 1, we get a distribution that looks like that. N equals 2, it get same distribution, but a bit less of this little bump here. I don't know, I'm just making this up. N equals 3, even less bumpy, and then on and on. So as n goes to infinity, what will the distribution look like? Our main tool for tackling the asymptotic distribution will be the central limit theorem. So what is the CLT, you may be asking? So for a distribution x, right, with expected value of x equaling mu and variance of x equal to sigma squared, which is less than infinity, right? So both the first and second moments have to be finite. Then for x bar equaling 1 over n times the sum of xi, so the sample mean, right, for the first n distributions, I guess I'll write x bar sub n. Then, as n gets bigger, we have that x bar minus mu, so the sample mean minus the population mean, over square root of sigma squared over n, converges in distribution to a normal distribution with mean 0, variance 1. When I say converges in distribution, what I mean intuitively is that the distribution will look more and more like this. So as n goes to infinity, our distribution gets closer and closer to. Couple of equivalent forms of the CLT. We have square root of n, x sub n minus mu over sigma converges in distribution to normal 0, 1. We have square root of n, x bar minus mu converges in distribution to normal 0, sigma squared. Note this is the variance, not the standard deviation here, right? Sigma squared is a variance. So yeah, I would say central limit theorem is probably the most important takeaway from your math stat class.